Hello, during this session I'm going to explain the nuances of work and energy, two things which I obviously always long to see more from my students. So let's start off with thinking about how to do some work. Well, work is the exchange of energy. So work equals force times distance moved in the direction of the force. W equals FD. So work is going to be measured in joules. My example here is a car is pushed with a force of 120 newtons for 10 meters against a resistive force of 20 newtons. So that means that the resultant force is 100 newtons. The 100 newtons acts for 10 meters. So that means the net work done on the car is 100 newton meters, or no, 100 newton meters, 1,000 newton meters, or 1,000 joules. That's the additional energy the car now has. And in this case, because it's been pushed along, it's pushing faster and faster, it's gaining kinetic energy. So let's think about kinetic energy now. Kinetic energy is the energy from mass in motion and is calculated by half mv squared, where m is the mass in kilograms and v is the velocity in meters per second. So for example, a 50 kilogram person running at 10 meters per second has 2,500 joules of kinetic energy. Looking at these two pictures, we can recognize the importance and the power of speed in these calculations. So if I have a 1,000 kilogram car, one traveling at 100 kilometers an hour and one traveling at 50 kilometers an hour, we've got to recognize the kinetic energy for the car which is traveling twice as fast is 4 times as big. So that means the accident is going to be 4 times as devastating, as 4 times as much energy needs to be dissipated in the crash. We've also got gravitational potential energy. This is the energy resulting due to objects being raised in a gravitational potential field. So when we lift an object, we do work on the object. In this case, the energy gained by the object is called the gravitational potential energy. So if they're thinking about work, work is force times distance. In the case of lifting something up, we're overcoming the force of weight. So that's mg times h, which is the height which is raised. So gravitational potential energy equals mass in kilograms times g times h, the height gained. So relative to what? Let's think back about gravitational potential energy is relative to a predefined zero. So 0 of GPE could be the ground or could be the top. We also have elastic potential energy. We should mention that as well. What we have is the potential energy of an unstretched spring is equal to 0. But if I stretch the string, it gains elastic potential energy. And this is calculated by half kx squared, where x is the extension from the unstretched position, and k is the factor or the constant relating to the specific spring. So this is known as the spring constant, and every spring would have a different value for k. That's another form of energy which could be applied, and as we can see here, this is interesting. If you apply a force on a spring, so force times distance is going to equal half kx squared. Thinking about the distance there, and one of the things to recognize in this important thing here is that the force is obviously going to be changing as the more you stretch the spring, the force required to move the spring changes as well. For this building, the law of conservation energy is never destroyed, it is just converted from one form to another. So examples of energy conservations would be a battery converts chemical energy into electrical energy, an electric motor lifting an elevator converts electrical energy into gravitational potential energy, and a moving vehicle uses its brakes to stop. The kinetic energy is converted into heat in the brakes. Now I should mention all of these examples are perfect physics exam examples. There's always some wasted energy somewhere here. So if you ever have a battery which is converting chemical energy into electrical energy, you may notice the battery gets hot, and that's additional wasted energy. An electric motor lifting up an object, again there's likely to be friction, so there'll be wasted heat energy and probably sound energy. And again, kinetic energy, although converted into heat energy, there may well be some wasted energy, for instance sound of the skidding brakes. And finally, a nuclear reactor converts nuclear energy into heat energy, and again some of the heat energy is likely to be lost in this situation. The conservation of energy means that something useful can happen. A falling object will convert all its gravitational potential energy into kinetic energy. So the loss in gravitational potential energy will be equal to the gain in kinetic energy. That allows you to do some calculations, not even needing to know the mass of the object, because that will cancel out on both sides, to work out the final velocity it will achieve as it reaches the ground. Converting work into energy, work is done on the force times distance moved. The work done increases the speed of the car as explained, so in this case work done is equal force times distance is equal to the gain in kinetic energy, half mv squared, assuming that the car was originally stationary. So that gives us an overview